Welcome to the KNX Introduction Training. This learning module is the start of an ongoing series of further course sections on KNX technology and corresponding topics. The introduction modules are intended to provide a basic introduction to KNX technology and provide initial knowledge. They are aimed at sales staff, KNX ambassadors, or other people interested in KNX. Many advantages and arguments are intended to support them in their daily work. Let's start with the first part of the modules. First, you will get an overview of today's agenda. You will learn the most important facts about KNX, and then take a look at the history of the system. In addition, you will be introduced to various cross-trade application areas. You will learn the first basic technical details of the system. At the end of this learning module, you will gain an overview of the broad Siemens portfolio KNX-based products, and you will see how you can expand your competence with further Siemens training offers on KNX technology. Before diving into the details of the system, let's first look at important key data about KNX. The KNX system is based on a globally recognized standard for the intelligent networking of building technology. Data is transmitted via a separate field bus system, which connects all devices with each other, regardless of the manufacturer. This creates a flexible, scalable, and future-proof network. How does it work? All KNX devices, whether sensor or actuator, can communicate directly with each other. There is no central control unit, but a decentralized intelligence of all KNX devices, and thus an intelligent interaction of all components. And how does the data transfer work? Typically, the data is transmitted via a special bus line. This line enables the exchange of control commands and status messages between all KNX devices. In addition to the classic twisted pair line, KNX also supports other reliable communication options such as radio frequency, RF, IP, or IoT. Communication takes place in the form of telegrams, which are clearly structured and prioritized. This ensures that all commands are executed reliably and quickly, even under high system load. Telegrams can be transmitted encrypted via the IP backbone as well as over the bus line. This ensures secure communication. This makes the system efficient, robust, and safe. And how will the system be put into operation? For this purpose, there is a uniform tool for commissioning worldwide, the Engineering Tool Software (ETS). Later, you will learn more about the importance of this tool and the different licensing models. Now that you have received some key data about the KNX system, let's take a journey back in time to the emergence and development of KNX as an open standard with international recognition and provide facts and figures about a growing global community. KNX as a global standard for building control can already look back on a 35-year history. As early as 1990, a handful of visionary European manufacturers in the electrical industry, including Siemens, founded the European Installation Bus Association, EIBA, to create a uniform standard for building automation with bus technology. The EIB protocol has been developed. The first EIB equipment was certified in 1992. In 1999, EIBA merged with the existing EHSA, European Home Systems Association, and BCI, Body Bus Club International, to form the EIB Association. The aim was to incorporate the strengths of the three existing protocols into a uniform standard. Finally, in 2006, the company was renamed KNX Association, headquartered in Brussels. The main goal of KNX was to establish an open standard that is manufacturer independent. This ensures interoperability. That means the exchange of data between different manufacturers. The international standardization results in a field bus system that works uniformly worldwide. The data exchange is always identical, regardless of the region or the manufacturer of the KNX product. KNX is a globally established and standardized technology. After many EIB and KNX products came onto the market in the 90s, KNX was recognized as the European standard EN 50090 for home and building automation in 2003. Further rules for bus systems were defined in CEN in 2005. Due to these European milestones, KNX has been recognized as an international standard, ISO IEC 14543-3 by the International Organization for Standardization, ISO, and the International Electrotechnical Commission, IEC, since 2006. Other milestones include inclusion in the ANSI standard in 2006, the recommendation for building automation as a standard in China in 2013, and the recognition of KNX IP Secure as an international security standard in 2019. After more than 35 years of successful history as the global standard for building control, numerous achievements and milestones, we look back on these success figures. There are currently more than 8,000 registered and certified products on the market. After registering with KNX, manufacturers can have their products tested in one of the 19 accredited KNX certification laboratories according to the KNX standard. This ensures the interoperability of KNX products. In addition, there are more than 500 KNX members worldwide, which consist of manufacturers such as Siemens. There are more than 500 accredited training centers worldwide in 71 countries. Siemens maintains its own certified KNX training centers, for example, in Germany, France, Belgium, Switzerland, and the United Arab Emirates. This has resulted in a worldwide network with more than 120,000 certified KNX partners. In addition, KNX is represented in almost all countries worldwide via the national groups and user clubs. The current success figures can also be read on the KNX homepage. To do this, they conveniently scan the QR code with their smartphone. KNX can be found in countless applications that make our everyday lives more comfortable, safer, and more efficient. So let's move on to the diverse and complex areas of application and application examples of KNX. Modern lighting technology dynamically adapts to time, presence, and daylight, creating the perfect atmosphere at all times, while minimizing energy consumption. So let's take a look at typical and innovative applications. The light thinks for itself. Indoor and outdoor lighting turns on or off automatically depending on the time of day, usage, or even weather conditions. The light adapts to you. You can individually determine the brightness, light color, and color temperature according to your needs or mood. With human-centric lighting, the system ensures the perfect interplay of natural and artificial light for concentrated work or relaxed breaks. The light reacts to you. Sensors detect whether someone is in the room and switch on the lighting only when it is needed, based on presence. And what's more, you can automatically call up individual scenes or constant lighting control. In conjunction with intelligent lighting, shading also plays an essential role, a space that automatically adapts to the light. This is not a vision of the future, but reality. Intelligent shading systems detect the sun's rays and automatically control blinds, roller shutters, or awnings. They follow the position of the sun and precisely regulate the edge of the shadow for optimum comfort and glare-free light. But the system thinks ahead. It is networked with heating, ventilation, and air conditioning and helps to save energy via climate-dependent shading control. Whether according to time, weather, or presence, the sensor-based control system reacts flexibly and ensures a pleasant indoor climate at all times. Closed blinds or roller shutters also offer basic protection and thus also increase the security of the building. The intelligent shading ensures that solar heat stays outside or is used in a targeted manner. But comfort doesn't stop there. The HVAC control system completes the interaction. The KNX system regulates heating, ventilation, and air conditioning in such a way that energy is saved and a feel-good climate is created. Rooms are individually tempered, adapted to use, time of day, or personal preferences. Sensors for temperature, CO2, and humidity, as well as window contacts, provide the data for needs-based and optimized control. And best of all, the regulation thinks for itself. It automatically adapts to seasons and presence. More than the three pillars: real-time monitoring through visualization and energy management. Efficient building management doesn't end with lighting, shading, and HVAC. The ability to keep an eye on everything in real time is becoming increasingly important. Visualization makes complex data tangible. Temperature, humidity, or switching states appear clearly on a central display. And best of all, the entire building can be conveniently controlled from here. But the visualization can do more than just display. It opens up a view of energy generation and consumption. Intelligent networking goes even further. PV systems, storage systems, and e-charging stations work hand in hand. The system ensures optimal use of renewable energies, efficient storage, and demand-based control of charging processes. And to prevent load peaks from occurring in the first place, load management takes over. It prioritizes consumers, reduces grid loads, and lowers energy costs. With lighting, shading, HVAC, and energy management providing comfort and efficiency, one crucial aspect remains: safety. Intelligent security and access systems close this circle. They provide comprehensive protection and convenient access. Sensors such as burglar and motion detectors, as well as door and window contacts, immediately detect unauthorized access and automatically trigger alarms. Users retain full control, even remotely. Buildings can be monitored and controlled via app, or notifications can be received in real time. Convenience and security go hand in hand. Intelligent door communication and access systems enable access via code, chip, or smartphone. And thanks to seamless integration with building management systems such as Siemens and fire protection systems, a safety net is created that knows no gaps. The key areas of application and advantages of KNX result from the wide range of fields of application. In a compact summary for you: comfort, automated control of light, sun protection, heating, ventilation, and more. Security, integration of alarm systems, access controls, and monitoring systems, as well as secure communication via encrypted data transmission. Energy efficiency, optimized use of resources through intelligent control. Flexibility, scalable and future-proof for residential and commercial properties. Networking, seamless communication between sensors and actuators via the KNX bus, IoT, and other systems. To get started, let's take a look at the technical aspects of KNX. We first compare conventional technology with KNX using a simple example, and then look at the different transmission media within the system. In conventional electrical wiring, the connection between the individual components is made according to the principle of point-to-point wiring. This means that each switch is directly connected to the respective consumer. For example, a lamp. This type of wiring is functionally unambiguous, but also rigid in its design. The control functions are hardwired, which means that any change or expansion of functionality, for example a switchable socket, requires physical rewiring. This leads to limited flexibility in the system structure and makes later adjustments or extensions much more difficult. Another feature is the lack of intelligence. Control is carried out exclusively locally, without any overarching logic or central coordination. As a result, complex automation functions or system-wide control are not easily possible. In addition, the wiring effort with this method is very high. Numerous cable connections and distributors are required for implementation, which not only extends the installation time, but also increases the use of materials and costs. In existing buildings, physical expansions are therefore only possible to a limited extent and at great expense. In this application example, the conventional installation with the help of KNX devices is to be replaced. Let's now take a step-by-step look at which components are needed and how data transmission works. First of all, we need a KNX power supply to supply the KNX devices with the necessary energy. Depending on the number of components in a KNX line, a supply with the appropriate output current is required. Furthermore, we need a sensor or an operating device to turn the light on and off, and finally an actuator or dimmer with outputs to control a consumer, such as a bulb or a socket. In our example, one relay output of the switching actuator is wired to the bulb and another output to a socket. The power supply and the switching output of the relay are supplied accordingly via the mains voltage. Via the green KNX bus line, all KNX subscribers of this line are connected to each other with the bus voltage. In order to determine which data should be sent via the bus, the smart devices, in our case the sensor and the actuator, must first be put into operation with the help of the ETS software. In the following, the procedure is now very briefly described. Addressing the participants in the line. With the so-called individual address, each device in our system is uniquely assigned to an area, for example, building, and a line, for example, floor. In our example, there is only one building and one floor, so the devices get the individual address 111 for the tactile sensor and 112 for the switching actuator. After addressing the devices, the desired functions of the sensor and actuator are parameterized with the help of the ETS. In order to transfer the corresponding information from the sensor to the actuator, so-called group addresses are created. These addresses are linked to the corresponding functions such as switch, status feedback, or dimming for the sensor and actuator. What happens now when the top button is pressed? The tactile sensor detects the button press and sends the group address 001 to the bus using the switch function. This information goes to all connected KNX devices in our line. All devices that know this address process the information and react accordingly. In our example, the switching output of the actuator is controlled and thus the light is switched on. With the lower button, for example, you could now control the switching output for the socket. Thus, we use another group address, the 002, to turn the socket on and off. With KNX, it is very easy to add additional control units, with which you can control the light or the socket manually or automatically. Compared to a conventional electrical installation, a considerable amount of wiring would be required for the function expansion. Functions such as complex logics or status feedback are hardly or sometimes not at all feasible with conventional technology. Let's take a look at two worlds: the classic electrical installation and the intelligent KNX world. In the traditional installation, everything is hardwired. Every function is directly connected to the consumer, rigid and unchangeable. In contrast, KNX relies on a bus system in which all devices are networked with each other via a common line or modern media, such as IoT. What does that mean? KNX creates flexibility. New functions can be easily added via software without dust and high wiring effort. While conventional devices work in isolation and without communication, KNX components constantly exchange data. Sensors report, actuators react. And the controls? Instead of complicated control panels and limited functions, decentralized intelligence takes over at KNX. Every device thinks for itself and enables complex functions. The result? With KNX, you not only have automation but also full control through visualizations, panels, and remote access. And even in the event of a failure, the system remains robust. Only the affected device and the affected function fail. The remaining devices continue to work without errors. In short, conventional means rigid wiring and a lot of effort. KNX means flexibility, communication, and future-proofing. Now that you are familiar with classic data transmission via the KNX bus cable and the differences to conventional installation, we will turn our attention to comparing the different available transmission media in the next step. Originally, KNX was developed as a so-called two-wire bus, twisted pair. As explained above, the information is transmitted via a pair of wires in a suitable line. Due to the signal properties, only twisted cables can be used. On this separate control line, there is only the KNX signal. This installation method is mainly used in new buildings and extensive renovations. The participants are supplied via the control cable at the bus terminal. In addition to the classic wired version, KNX has also been bringing wireless freedom since 2002. Buildings can be intelligently networked with wireless, without any cables. Perfect for listed buildings such as churches or museums. The devices are often battery-operated and can be placed flexibly, without any structural interventions. KNX is growing with the requirements. Even distant buildings can be connected to each other via IP and Ethernet. This creates a uniform system across buildings or locations, particularly powerful for main and area lines with fast data transfer and power directly from PoE. Building on the previous milestones, a new technology has now arrived in the KNX world: Internet of Things, or IoT for short. Sensors and actuators interact via direct IPv6 communication. The Wireless Mesh Network Protocol thread offers secure and flexible options for retrofitting building parts and networking them with the existing TP system. After getting to know the technical details, we would now like to take a closer look at project creation with the ETS tool. Here we take a closer look at the software itself and the different license models. Engineering tool. Software, ETS for short, is a manufacturer-independent software for all KNX devices. The software is developed in Brussels together with other software companies and is the software to be used worldwide for KNX projects. The tool supports all project planning phases, such as planning and configuration, addressing and parameterization, commissioning, and maintenance. No other tools are necessary. It is therefore important to emphasize once again that the ETS is completely manufacturer independent and is therefore compatible with all KNX products certified worldwide. ETS is a software that has been tried and tested over decades and is constantly evolving. Experience and feedback from practice are incorporated into the further development of the software. We have now reached the 6th generation. ETS is backwards compatible. This ensures that projects that were created with older versions, for example, ETS 4 or ETS 5, can also be loaded into the current ETS version. For more information, simply use the link or scan the QR code. Let's now get an overview of the KNX Association's licensing models with regard to the ETS. The ETS demo version provides free access to the ETS software and allows you to insert up to 5 KNX devices into a project. The use of ETS apps is not provided for in this version. All ETS versions are fully compatible with Windows. The demo version is particularly suitable for getting a first impression of the software. It allows the creation of a small test project, for example with a sensor and an actuator, to try out basic functions such as light switching and dimming. The ETS Lite version is available from €200 in the official KNX shop and allows the integration of up to 20 KNX devices per project. In contrast to the demo version, all ETS apps can be used without restrictions. The license is granted exclusively as a cloud license, a difference from previous license models. This version is particularly often used by educational institutions to implement smaller projects as part of lessons or training. The ETS Home version differs from the Lite version in 2 main ways. The price is €350, and up to 64 KNX devices can be integrated per project instead of 20. This version was developed by the KNX Association specifically for homeowners to provide a cost-effective solution for their own property. With the limit of 64 participants, many small to medium-sized projects can be implemented without any problems, a major advantage. Adjustments and changes, such as the switching times of motion detectors or the dimming values of the lighting, can be made by the user independently without having to commission a KNX specialist partner. However, for extensive changes or complex functions, a certified KNX expert should still be consulted. Finally, the ETS Professional License represents the most comprehensive version of the ETS software. For a one-time price of €1,000, it offers the full range of functions in terms of functions and the number of devices or projects. The license can be used either as a cloud license or as a USB dongle version, which allows maximum flexibility in use. This version is the standard solution for system integrators, specialist companies, and all those who regularly work with KNX projects. It is indispensable in such cases. Finally, a short word about KNX's update policy. Software updates within an ETS generation, for example, ETS 6, are free of charge. Version jumps, for example, from ETS 5 to ETS 6 or later to ETS 7, are usually subject to a fee. Follow the QR code for more information. With its various licensing models, the ETS software offers a suitable solution for every user group. Finally, there is an overview of the main advantages of the software. With the help of ETS, the user is offered a globally standardized interface for planning and configuration. From small test projects to large installations with thousands of devices, there is a high degree of flexibility for any project size. The modular range of functions also ensures that functions can be expanded through various ETS apps or regular updates and further development of the software. All KNX certified devices can be integrated regardless of the manufacturer. This results in an intuitive and user-friendly interface, which also offers very good documentation for projects. From free entry to full version for professionals, KNX offers license models for every need. Conclusion: ETS is not just a tool, but a future-proof foundation for intelligent building automation. Scan the QR code to get more information about the software from the KNX Association. After looking at the basics and advantages of KNX over conventional electrical installation and gaining an insight into the ETS software, we now turn our focus to Siemens' KNX portfolio. Siemens offers a comprehensive range of smart KNX products based on the international KNX standard, covering the following areas. Lighting. For optimal lighting control, a versatile portfolio of switching and dimming actuators, multifunctional actuators, DALI gateways as well as motion and presence detectors are available. Solar protection and shading. Efficient lighting control only works in combination with intelligent shading. Thermo-automatic functions contribute to the optimization of the indoor climate. The central components in this area include our blind and solar protection actuators in a wide range of designs for different drive types, which can control interior and exterior curtains, windows, and awnings. Weather stations interact with the solar protection actuators by collecting weather data. Room temperature control and HVAC. Our thermal actuators, various valve and air damper actuators, form the basis for efficient control of water and air-based heating and cooling systems. The portfolio is complemented by our thermostats, sensors, and room control units, which enable convenient operation and clear display of room functions. Finally, we take a look at selected system devices. These include the IP secure routers, which enable a secure topological connection between different KNX lines and areas. An IP router or an IP interface also enables fast and direct access to the system via the network. KNX IoT router for easy connection from KNX TP to KNX IPv6. The Thread Border Router manages the connection of the wireless participants in the thread-based mesh network. The KNX power supply provides the necessary energy for KNX subscribers. In addition, we offer a variety of gateways that enable a connection to other bus systems such as BAGnet. Curious? Now that you have gained an insight into our product portfolio, we would like to recommend our KNX TD to you. In this comprehensive product database, you will find detailed technical information on the installation and function of all KNX components in addition to ETS product data. You'll also get access to information about technical support, add-on software, firmware updates, and more. Further information on our portfolio can also be found in our portfolio overview brochures in English and German. In addition, our HIT portal offers comprehensive content on BIM and CAD data, as well as various declarations of conformity, EPDs, and other relevant documents. Siemens KNX Training Overview. Finally, we would like to explain the advantages of certified training, give you an overview of our KNX training program, and introduce our training components. A great special feature of KNX certified training courses is the worldwide standard of the content to be taught. In various training cities worldwide, a minimum amount of knowledge is imparted to the participants, depending on the training carried out. KNX certification therefore offers several advantages, both for companies and for individuals working in the field of building automation. Here are the main reasons. Professional recognition. The certification confirms in-depth knowledge of KNX technology, installation, programming, and commissioning. It is internationally recognized and strengthens credibility with customers and partners. Market access and competitive advantage. Many tenders and projects require certified KNX partners. It facilitates access to new markets and customers, especially in the professional environment. Access to resources. Certified partners get access to exclusive tools, support, and training materials from the KNX Association. Use of the KNX logo and entry in the official partner directory. Quality assurance. The certification ensures that installations are carried out in accordance with the KNX standard. This increases the reliability and maintainability of the systems. Network and further education. Participation in KNX events, trade fairs, and further education. Exchange with other certified professionals and companies. Would you also like to become a part of a worldwide community of the KNX Association? Then I recommend Siemens' wide range of certified KNX training courses for every level of experience. Whether basic courses, in-depth training courses, or product-specific training courses, everyone will find the right format for their needs here. In addition to German and English language online training courses such as this one, numerous face-to-face training courses are also available. You can get an overview of the available locations and offers on the next slide. Simply scan the desired QR code for classroom training in Germany, in Switzerland, or the online training courses, and receive further information about the training offered by Siemens. Curious about what to expect in a KNX training course? Today, you have gained a first insight into the world of KNX technology and our product solutions. But theory is only the beginning. In our training courses, we go one step further. With the Siemens training case, you can put your knowledge directly into practice. Experience how intelligent building functions can be programmed live and controlled, from lighting and shading to HVAC and security. In this way, theoretical knowledge becomes real know-how that you can apply immediately. Scan the QR code and discover all the details about our training case. Thank you for your interest in our KNX base module. This web training is the prelude to a whole range of other content on the topic of KNX. Stay tuned and follow our upcoming training offers.